Chapter 8, Straight Line. The objective of this video is to learn how to calculate the gradient of a straight line from the coordinates of 2 points. Lines are made up an infinite number of points. This video deals with those points which form a straight line. Each point of a straight line, when it is plotted on a pair of axes, will have particular coordinates. For instance, the coordinate for point A is 1 and 3, and the coordinate for point B is 5 and 7. The relationship between the coordinates of the point of a straight line can give us information about the straight line. So, what information can we read from the coordinates? The very first will be the gradient. Gradient refers to the steepness or the slope of the straight line. Gradient of straight line is a constant, which means it doesn't change. In order to calculate the gradient, we have a few equations. And now I would like to introduce the first, which is gradient equals to rise over run. In order to use this equation, we need to pick 2 points on the targeted straight line. For this example, I pick point A and point B, and let's start from point A. In order to travel from point A to point B, I can choose to travel from A to this point, because the movement is a vertical movement, so I call this the rise. After that, I continue the journey to move from this point to point B. Because the movement is horizontally, so I call this run. Gradient is given by rise over run. Let's look at the value for rise. From A, we rise from 3 to 7. So we rise 4 units. From this point, we run from 1 to 5. So we run for 4 units as well. So the gradient of line AB is equals to 4 over 4, which is equals to 1. Of course, rise over run is not the only equation that we can use to find the gradient. In the next video, I shall share with you the other equation. Thank you. From the previous video, we have learned that in order to find the gradient of a straight line, we can use rise over run. Rise refers to the vertical movement, and run refers to the horizontal movement. My question now is, does the sequence of the rise and run matter in calculate the gradient? Let's look at this example now. In the last video, the sequence I use is I move from A to B. Now, I want to reverse the process to move from B to A. When I move from B to A, firstly, I need to go down from B to this point, and then I move to the left until I reach point A. From B to this point, I go down for 4 units. Because I go down, so I assign a negative sign for the movement. So rise is equals to -4 instead of +4. When I move to the left, I assign a negative value for the horizontal movement. So the run is equals to -4. By using the same equation, rise over run, so the gradient is equals to -4 over -4, and again it is equals to 1. So from here, it is very obvious that the method of the rise and run does not. The sequence of the rise and run does not matter as long as you use the correct equation. And the correct equation is gradient equals to rise over run. From the previous video, we learned that gradient is equals to rise over run. In other words, rise is equals to the vertical distance between 2 points. Vertical distance between point A and point B, for instance, over run is equals to the horizontal distance between 2 points. The horizontal distance between 2 points. This is a very useful equation, and we can use it to represent any 2 points on the line. For example, if we have point 1 with the coordinate of x1 and y1, and point 2 with the coordinate of x2 over y2. So in order to find the vertical distance, we just need to find difference between y1 and y2. So the gradient is equals to y1 minus y2 over the horizontal distance, where the horizontal distance can be found by finding the difference between x1 and x2. x1, y1, x2, y2 can be the coordinates of any 2 points. For instance, if I choose A to be my first point, so x1 is equals to 1 and y1 is equals to 3. x2 is equals to 5 and y2 is equals to 7. By using this equation, y1 minus y2 is equals to 3 minus 7 over 1 minus 5, which is equals to -4 over -4, and the result is 1. So we get the same gradient. In order to use this, we need to assign the coordinates we choose as x1, y1, and x2, y2. And all students have to take note that it does not matter which point we choose to be our x1 and y1, and x2 and y2, because the gradient will be the same, which means that I can choose B to be my x1 and y1, and A to be my x2 and y2. But when I calculate the gradient, I use y1 minus y2. So y1 minus y2 is 7 minus 3, and x1 minus x2 is equal to 5 minus 1, which is equals to 4 over 4, and again the gradient is equals to 1. From the previous video, we have learned that there are two equations to find the gradient. The first is given by rise over run, and the second is given by y1 minus y2 over x1 minus x2. We use the first equation especially when the straight line is shown in a pair of axes. Otherwise, we may need to sketch the position of the 2 points. But we can use the second equation as long as we know the coordinates of 2 points on the straight line. For instance, P and Q are 2 points on a straight line, and in order to find the gradient, I just need to assign x1 and y1 as the coordinate of P, and x2, y2 as the coordinate of Q. And please remember that the point that is to be assigned as x1 and y1 does not matter. I can reverse. But for this instance, I choose P to be my x1 and y1, and Q to be my x2 and y2. So let's plug in the value into this equation. y1 is 3 minus 2, 3 minus 2, over x1 minus x2, which is 5 minus negative 1. 5 minus negative 1. This is equals to 1 over 6. So the gradient of PQ is equals to 1 over 6. The gradient of PQ has a positive value, which means that the line is going up. Without sketching the position of P and Q, we can still find the gradient of PQ as long as we know the coordinates for P and Q, or any 2 points on a straight line, by using this equation. Well, let's put on for one more example. If we have A as 4 and 6, B is equals to 5 and negative 1. What is the gradient of PQ? So the gradient of AB is equals to y1 minus y2. 6 minus negative 1. 6 minus negative 1 over x1 minus x2. 4 minus 5, which is equals to 7 over negative 1. So the gradient of AB is equals to negative 7.